Good morning, students. Today we are going to see with the topic interference in thin films. So in this, let us consider a thin film of transparent material of refractive index mu. So this is a transparent material we are considering. Okay, and this material has a refractive index mu and a thickness d. Okay, so this has a thickness of d and a parallel beam of light which is incident on the film at an angle I. Okay, so this is a parallel beam which is incident on the surface, and that incident angle is what? I. And now the wave is being divided into two parts at the upper surface. So this is upper surface. At this point the wave is going to be divided into two parts. Okay, so one is said to be reflected, the other is refracted. Okay, so one part is reflected and the other part is refracted. Again, same way, at this point this get refracted at one side and it gets transmitted out. So transmitted wave, what it does, it comes out. Same way here also, one will be transmitted, other will be refracted, and at this point one is refracted and the other is transmitted. Okay, so it goes on like this way. So one ray is being split on in this manner as refraction and transmission. Okay, and the lowest surface is divided into two parts. One is transmitted out and the other is reflected back, and the reflected as well as the refracted waves are sent by the film as multiple reflections. Okay, so it goes on such a way that it goes on with a multiple reflection. So இதே மாதிரி என்ன இருக்கு, multiple reflection போயிட்டே இருக்கு. Okay, the interference is produced by both reflected and transmitted light. Okay, so இந்த reflected இந்த transmitted இருக்கிறதுனால தான் என்ன ஆகுது, நம்மளுக்கு interference produce ஆகுது அப்படின்னு சொல்லியிருக்காங்க. Okay, so interference is due to what? Reflected and transmitted light. Clear? So this is the ray which is entering and this has the angle of incidence I. At this point it is partially reflected and refracted. Okay, so this is angle of refraction and this width it is given as d, and at this point it is partially reflected and transmitted. Okay, again here it is refracted and reflected and refracted. Okay, here it is transmitted and refracted, so it goes on in this way. Okay, and in this we are going to see the condition for transmitted as well as a reflected light. So transmitted and reflected light, how they are. Okay, so that is what we are going to see in this. First we are going to see with the transmitted light. The light which is transmitted may interfere to produce a resultant intensity. So the transmitted light at one point, what happens? It also may interfere, okay, and it produces some intensity. Let us consider the path difference between the two light waves transmitted from B and D. Okay, so this is a path. Here is B and here is D. Okay, so this path difference between B and D. Okay, and we are considering with that the two waves move together and remained in phase up to B. Okay, so here what happens is there are two waves which are moving here. So up to B it is same. Okay, there is no change in that. Then after B what happens is it splits. Okay, here the splitting occurs. Okay, where the splitting occurs at the point B. Okay, splitting occurred. The extra path traveled by the transmitted wave from D is a path inside the film BC plus CD. Okay, so this is BC and CD. Okay, so BC plus CD, that is a path traveled. Next we are going to do some approximation. What we are going to do approximately is consider that the value of the incident angle is equal to 0. So considering I is equal to 0, then this B and D we can consider that they are very close to each other. Okay, so the extra distance traveled is twice the thickness, we know. So this is what, this value we know, which is D. Yes, and here it is traveling from B to C and C to D. B to C we are writing as D. Again C to D is written as D. So it is d plus d, it is given as 2d. Okay, so the distance traveled is 2d. Next is the refractive index. If you are considering as mu, then the path difference is given by this refractive index into this distance. So 2 mu into d. This gives your path difference. Okay, so del is equal to 2 mu into d. This we are going to write for constructive interference. We'll get, for condition for constructive interference is 2 mu d is equal to what? N lambda. Okay, so this is constructive. Same way, if you are considering for destructive interference, 2 mu d, which is equal to 2n minus 1 into lambda by 2. Okay, so for constructive interference it is n lambda, and for destructive interference it is 2n minus 1 into lambda by 2. Clear? So this is all about the transmitter light. Clear? So next is we are going to see for reflected light. Yes, so for reflected light, let us consider the path difference between the light waves reflected at the upper surface and the other wave coming out at the sea after passing through the film. Okay, so we are considering two waves. Okay, so from this A, okay, and from this C. Yes, so there are two waves which are passing. Yes, and the additional path difference coming out from C is given by AB plus BC. Okay, so from here it is moving to B, then to C. Okay, so it is AB plus BC. As we know already, AB can be written as D, same way BC can be written as D. So it is D plus D, which is equal to what? 2D. And if the refractive index is mu, we get 2 mu into D. That gives your path difference. Okay, so same as a that transmitter light. Okay, and here the first condition is for constructive interference, we get 2 mu d plus lambda by 2. So why we are taking plus lambda by 2 is because for reflected way there is an additional path difference of lambda by 2. Okay, so here we are writing as plus lambda by 2. Same way, now if you bring this to other side, we get n lambda minus lambda by 2. Yes, take the LCM. So 2n lambda minus lambda divided by 2. Yes, now in this, taking again lambda by 2 outside. Yes, so we get lambda by 2 we have taken outside, then the remaining is 2n in this. Okay, so it is 2n minus lambda we have taken out, so remaining is 1. So we are getting the answer as 2n minus 1 into lambda by 2. So 2 mu d is equal to 2n minus 1 lambda by 2. This is for constructive interference. Same way, next is when you are considering for destructive interference, path difference is what? Additional lambda by 2. Now bringing this lambda by 2 here, and this also, if you multiply this inside, yes, so we get 2n into lambda by 2 plus lambda by 2. So this is when you are multiplying this inside, 2n into lambda by 2. This is again 1 into lambda by 2. This lambda by 2, if we take this side, we get minus lambda by 2. Okay, so plus lambda by 2 minus lambda by 2 get cancelled. Same way, 2 and 2 get cancelled. So we get 2 mu d, which is equal to n lambda. So this is a condition for destructive interference. Yes, clear? So this is about the interference in thin films. So interference in thin films we have seen for two lights, which is transmitted as well as a reflected light. Clear? Thank you.